Hello everyone, class 12th topic is reaction of alcohol with metals. And what kind of metals which are more electropositive than hydrogen? More electropositive means they have a more tendency to donate electrons. For example, if I compare sodium and hydrogen, sodium can donate electron easily as compared to hydrogen. So what we will say, sodium is more electropositive than hydrogen. Other metals are there like magnesium is there, aluminium is there, zinc is there, sodium is there, potassium is there. So these metals are more electropositive than hydrogen. Now let's check how alcohols react with these kind of metals. First of all, let me tell you the reaction. This is the general formula of alcohol. And if we are using metal which is more electropositive, more electropositive than hydrogen, so hydrogen will be replaced by metal and H2 gas will generate. And the compound which is generated over here, we call it metal alkoxide. Metal alkoxide. Because in this compound, oxygen is carrying complete negative charge, which will be balanced by positive charge of the metal, and between oxygen and metal, there will be ionic bond. Ionic bond. And this part is alkyl part, we know, and this is oxygen with a negative charge, so we call it oxide. So alkyl and oxide, so that's why we are calling it alkoxide, which is balanced by a metal, so we are calling it metal alkoxide. Side product will be hydrogen gas. Now let's check how that reaction is happening. In alcohol, as we know, oxygen is more electronegative than hydrogen. So these sigma bonded electrons are more toward oxygen side. They are connected with oxygen more as compared to hydrogen. So partial negative charge is developed and hydrogen will carry partial positive charge because this electron is getting shifted toward oxygen. So hydrogen is losing its hold on oxygen, on its electron. So that's why a positive charge will develop. Whereas oxygen is getting extra electron of hydrogen to its side, that's why an extra negative charge is developed. Now in such condition, if metal we are bringing, metal always have a tendency to lose electron. So suppose this metal has lost one electron. Obviously after loss of electron, metal will turns to plus one particle because number of protons are increased here by 1, so that's why plus 1 charge will be there. Now this electron is a negative particle. As we know, electron is a negative particle, is looking for a positive particle. Where we have positive particle? Hydrogen is here as a positive particle, so that's it. This electron is going to attack on this. Now when electron will go toward hydrogen, this bond will completely break because automatically already it is a weak bond because electron transfer is there toward oxygen side and one more electron is coming toward hydrogen side, so bond will completely break. And how? Both electrons will completely shift toward oxygen, due to which this part will become this one. Oxygen will have third pair of electron around it, this one, and minus 1 charge due to extra electron of hydrogen. So this part is known as alkoxide part. Alkoxide ion you can call it, which will be balanced by this positive particle, cation of metal will attack on it and you will have ROM there. Between O and M there will be ionic bond. Here we have an ionic bond. So this is known as metal alkoxide. Now hydrogen after gain of one electron will become H free radical, hydrogen free radical it is. Look, one electron was lost by hydrogen toward oxygen, but at the same time it got electron from metal side. So overall it will become a neutral particle, this hydrogen free radical. Now we know such hydrogen free radicals are highly unstable, so it will combine with another hydrogen free radical which will be generated from such same reaction. another same reaction will happen here. This is a first reaction due to which one H free radical is generated. Another reaction second time will happen, another free radical will generate. So they will combine to produce hydrogen gas. That's it. This is very easy reaction. Now you can check here, hydrogen is working as a positive particle, means acidic hydrogen. So that's why in these reactions alcohol is also showing acidic behavior. So this reaction is coming under the category of those in which alcohol is showing acidic behavior. Now if we try to write it in a balanced form, please check how you will write. Two molecules of alcohol are reacting with one metal atom, M plus 1, and they are losing one electron. These electrons are going toward hydrogen side, due to which ROM, here H free radicals are generated and they will combine to produce H2. So in balanced form you have to write this equation like this: ROH plus 2M making 2ROM plus H2 gas. Metals which are losing one electrons like sodium, potassium, for those metals we have to follow this balanced equation. But metals which are losing two electrons, only one metal atom is enough for the reaction. For example, two ROH molecules, and suppose we are dealing with metal who can lose two electrons like magnesium, calcium. After loss of two electron, plus 2 charge will develop 2 electron. Out of 2 electron, 1 electron will go toward this hydrogen and 1 electron will go toward this hydrogen. Equal distribution. Bond breakage will be there. So 2 times RO negative will generate, and 1 M plus 2 is enough to balance them. Minus 1. So M plus 2 is enough to balance them. This is again metal alkoxide, and from here hydrogen free radical, and from this side also hydrogen free radical will generate, which will combine to create hydrogen gas. Now in these reactions alcohol is also showing acidic behavior. Okay, that's it. By yourself try reaction of alcohol, different alcohols like ethanol, propanol with different metals like sodium, potassium, magnesium, aluminium, zinc, and according to number of electrons please try to balance the equation. Thank you very much for watching the video.